the actual size of protoplanets and stellar metamorphosis. If you go on Wikipedia and you type in protoplanet, you'll see something like this. A surviving protoplanet, Vesta. They call this a protoplanet because to them, to build a planet, you start from small bits, which then clump into bigger bits, which then clump into bigger bits, which clump into asteroids, which clump into protoplanets. But that doesn't make any sense at all, because what's doing the clumping together? What's providing the heat? What's providing the gravitational field to capture the material? Where can something like this actually occur in nature other than a star? The stars, ladies and gentlemen, are the protoplanets. These are the young, hot protoplanets that clump together the asteroids, which are the stellar guts that are remains of very ancient stars. This isn't something that formed from a protoplanetary disk. This is the remains of a piece of the crustal material or mantle material of a very dead old star that's been smashed to bits over hundreds of millions, billions, quite possibly trillions of years. This isn't a protoplanet. A protoplanet is incredibly massive. In this paper, I'll read a few things out for you guys. In stellar metamorphosis, young stars are planets in their plasmatic state, meaning they are not protoplanets. Meaning they are protoplanets, I should say. Establishment science has protoplanets as being smaller than the moon, which is incorrect. Reasoning is provided. In stellar metamorphosis, stellar evolution is planet formation. Everybody knows that. This means the Earth was once incredibly massive and plasmatic. Hi, Celeste. This foundational understanding of the true size of protoplanets is rooted in multiple principles of stellar evolution. Now, I drew up these principles to make it easier to understand in the long run. Of course, these principles can change. Number 1, the energy mass dissipation principle. This means protoplanets start out incredibly hot and massive and eventually cool down to their lowest energy state and lose the majority of their mass. This means protoplanets are in no way rocky or metal objects that have only fractions of the masses of small moons. A protoplanet is something that's incredibly hot, incredibly massive, incredibly energetic. That's the object that can clump together interstellar shrapnel, heat it up, collect it all together, and form it into the center again, recycling the material back into a brand new planet again. It's an interstellar recycling machine is what a star is, essentially. That's a bit of an abstraction. Of course, it does a hell of a lot more than that. Principle number 2, the plasma to rock and metal principle. Protoplanets start out as plasmatic, which are called stars, and then cool, collapse, become more dense and rocky metal stars. So they start out really big and hot, plasmatic, and the protoplanets collapse and collect the material in their centers, forming the planetary embryo inside their interiors. Number 3, foundational structure principle. What this means is that any object that has a differentiated interior was a much larger object in its past, and places the possibility that impact remains and planets can be classified by an internal physical understanding other than orbits or current size. The astronomers, when they classify the objects, they look at their orbits and they look at their current size, because to them, orbits are numero uno and their current size is numero uno, because they have planets forming as is. In this theory, planets do not form as is. Planets are evolutionary in nature. They evolved for much hotter states, much hotter, more energetic states, and have lost a vast proportion of their mass, and their elemental compositions have changed dramatically over many hundreds of millions, billions, and even trillions of years. And finally, last but not least, this is possibly the most important principle of all of them. Number 4, the accretion principle. And what this states is only objects with large surface areas and gravitational fields can accrete matter. This means protoplanets have to be really, really, really big. Now, this is very easy to understand. There's a good analogy for this. If you're going to go outside and collect rainwater, if you're collecting rainwater, what do? you get a very large surface area, do you not? Do you go outside with a cup or a thimble and run around trying to collect rainwater in this little thimble or cup? No, you won't collect that much rainwater doing that. If you want to collect a lot of material, you make a huge surface area, such as maybe a roof of a house, and you use those blue barrels to collect it down the gutter. Or you get tarps out there and you place tarps in a convex orientation and you poke a hole in the center and you collect the rainwater that way. In other words, if you want to collect things in outer space, you don't collect them by using really tiny little objects all collecting themselves. That doesn't make any physical sense. If you're going to collect objects to make something the size of the Earth, you need something with an enormous surface area and an enormous gravitational field to pull in material from interstellar space. And that's exactly what happens with stars. The stars are the giant tarps that collect the interstellar shrapnel and collect it into the center, forming the planet. And we can see this process in our solar system of various stars at various stages of evolution. Neptune, Uranus, Earth, somewhere down here. Venus is a dead one. It can no longer collect a lot of material. And the rate of collection of material that a star can do is dependent upon how large it is. So for instance, the sun can collect a hell of a lot more iron and interstellar shrapnel than can the moon. And the moon can collect a hell of a lot more material than Vesta, and so on and so forth. The smaller you get, the more likely it is that that material can't collect anything at all, because its gravitational field is basically so weak that objects would just zoom past one another. And number two, the surface area of these objects is so small in comparison to the solar system as a whole that, again, they'll zoom past each other. But what astronomers do is they say, well, these objects that are clearly always just zooming past each other are somehow able to clump together to form something as massive as the Earth, which is, to be honest with you, it's irrational. But that's the dogma, and somehow that's still taught at the universities. But anyways, there that is. Protoplanets. They have it completely backwards. The astronomers have it completely backwards. And it's similar to back in times of Copernicus, where the major issue was, if Earth is orbiting around the sun, why is it that the Earth appears to not be moving and the sun clearly moves across the sky? To say that it's the Earth that's moving around the sun, well, that's irrational. That's stupid, because clearly you can see the sun moving. And Copernicus was like, no, it's actually the Earth moving around the sun. So when people would say, well, you're ridiculous, it's like, well, that's the only thing that makes sense. That's how you can make the wandering stars that have weird orbits go back to normal. Because if you place the Earth, if you move the Earth's position in a different position, then the other objects, they become a regular circular orbits. And there was a diagram in one of his books that shows that. And a similar thing is true with this theory, but not exactly. If you have the location for accretion inside of stars, then you get rid of the need for a nebular disk. You get rid of the need to account for the angular momentum problem. You get rid of a lot of different issues, such as why is the Earth differentiated? Why is Mercury, Mars, and Venus differentiated? Why is there a smooth continuum with their total axis angular momentums? Why are there elemental abundance differences? All the differences with the objects in our solar system can be accounted for if they're viewed as being evolutionary in nature and not forming as is, as the dogma accepts as being true. Because remember, they don't look at Venus, they don't look at Mars, they don't look at the Sun, they don't look at Neptune, Uranus, Saturn, Jupiter as forming as evolutionary structures. They view them as forming as is. So there's no evolutionary line for them. They don't do this. They just form in little discrete boxes. But this talk is way long enough. Baz, I'm gonna go ahead and write a few things down, and I'll get back to you. All right, later, y'all.